Hello, in this lesson we're going to learn about normal forces and how to identify it in a problem. Alright, so let's start with the definition of normal forces. Let's imagine we have this book here on this table, and well, we know that this book has a mass and therefore it has a weight, and it's pointing down because of gravity, right? And we also know that this system here is in equilibrium. Nothing is moving. Well, to compensate this force pointing down, we need a force pointing up. Otherwise, everything would go down here. And for this force here that's pointing up, we call it the normal force. This force is a reaction force from the table on the book. And so the normal force is the force perpendicular to the surface of contact between a load and its support. Alright? And because of this normal force here, we have this equilibrium. Another example, for example, this Atlas, the Atlas sculpture here, he's carrying the world on his back. So the planet has a mass, so it has a weight. And to compensate, in order for him to carry the world, it needs a normal force on its surface, in this case his back. And also this force is transferred to his feet and to the ground. Otherwise he would be going down, right? Now we have equilibrium. Just be careful because the concept of normal forces can be misleading sometimes. Remember, it's a force always that's perpendicular to the safe surface of contact, alright? So for example, in this image here, the normal force, we have an inclined plane. So the weight of the small cart here is pointing down, of course, because of gravity, but the normal force is not pointing down. It's pointing this direction here, perpendicular to the surface, alright? A lot of people sometimes just think as the normal force as opposite of the weight, but actually it's a force that's perpendicular to the surface of contact, alright? Okay, so let's apply the concept of normal forces in an example, alright? We want to calculate the weight and normal forces for the system here. We have a car that's in an inclined plane, okay? The plane is inclined 30 degrees in relation to the surface here, and the mass of the car is 1,000 kilograms. Well, we have then a force that's pointing down, that's the weight, okay? And a force that's pointing up, perpendicular to the surface of the load, in this case the normal force. These are the forces we want to find. We can just draw the forces here, and let's establish the x and y axis like this, alright? So it's easier for us to calculate. So we have a 30 degrees angle here. It means it's the same, this is a right triangle. That's the same 30 degrees angle right here. So to calculate the weight, well, it's easy, right? We know that the weight here, the weight force is mass times the gravity acceleration. So it's 1,000 times negative 9.8. So the weight is negative 9,800 newtons. This negative sign here just means that's pointing down, alright? It's the opposite, it's pointing down because of the system here we considered, alright? The x and y axis are up and right are positive, so the weight is on the negative side, okay? Now to calculate the normal force, we first need to know the weight in the y direction here. So, because everything is in equilibrium, the normal force needs to compensate the weight force in this direction here. Alright, so the weight in the y direction is the weight times the cosine of 30 degrees, and it gives us negative 8,487 newtons. Well, the normal force should be the same value but in the opposite direction, pointing up. So it's positive 8,487 newtons in the opposite direction. Alright, now it's your turn to think about it. We have the system here. We did the equilibrium for the y direction. Alright, we found the weight and normal forces. But imagine that the car is not moving. Okay, so what is the friction force in each tire so the car doesn't move? So remember, we have a component of the weight force pointing down, so we need a friction force in each tire to compensate this weight component here. So think about it, do your calculations, and write your answers in the comment sections.
Thank you for watching this video. Hope you have a great day ahead, and we'll see you later.